Welcome to our third webinar on cylindrical roller bearings. Today we'll give you a compact overview of special solutions for high loads, covering full complement and multi-row bearings, their designations, and the various designs available. We'll start today with full complement bearings, what makes them special and how they are designated. We'll then take a look at multi-row bearings, followed by a discussion of seals and suffix designations. After that, we'll cover high-precision cylindrical roller bearings, including their tolerances and suffix designations. We'll wrap up with a brief preview of our next webinar. A full complement cylindrical roller bearing is a radial roller bearing, one without a cage. This means it can accommodate the maximum number of cylindrical rollers, which significantly increases the bearing's load capacity and rigidity. Full complement bearings are therefore ideal when very large radial loads need to be accommodated. However, permissible speeds are lower because without a cage, the rollers sit directly next to one another. A cage, by contrast, separates the rollers, reduces friction, and enables significantly higher speeds. At Schaeffler, the designation for these bearings begins with SL, standing for heavy load. The series is called SL18. In these bearings, the outer ring has one fixed rib, and the inner ring has two fixed ribs. The specific bearing series, and therefore the dimensions, are defined by two additional digits: 18, 22, 29, or 30. A further series is the SL1923. Cylindrical roller bearings of this design have two fixed ribs on the outer ring and a self-retaining roller and cage assembly, while the inner ring has only one fixed rib. This is followed by the bore identification number. Other manufacturers use slightly different designations. SL18 is replaced by NCF, and SL1923 corresponds to NJ23 with the suffix V for full complement. Multi-row cylindrical roller bearings contain several rows of cylindrical rollers, making them particularly well-suited for high radial loads, offering even greater rigidity than single-row bearings. They are especially useful in applications where a thin cross-section ring is required. The designation builds on that of the single-row design and is simply extended by adding a second N at the beginning. This design combines the advantages of both concepts: a maximum number of rollers thanks to the full complement design, and two rows through the double row configuration. The bearings are self-retaining and feature a circumferential groove and lubrication holes in the outer ring, which significantly simplify lubrication. They are particularly suited for applications that must accommodate not only high radial loads, but also high axial loads. The individual variants differ in the arrangement of ribs on the inner and outer rings. Here are a few examples. The SL02, known at other manufacturers as NNCL, has three fixed ribs on the inner ring. The outer ring has no ribs. The SL1850, or NNCF50, also has three fixed ribs on the inner ring, but additionally features one fixed rib on the outer ring. And the SL01, equivalent to NNC, has three fixed ribs on the inner ring and two fixed ribs on the outer ring. Sealed cylindrical roller bearings offer a number of advantages. The seals reliably prevent dirt, dust, or moisture from entering the bearing, while simultaneously retaining the lubricant inside. This significantly reduces maintenance requirements, as relubrication is needed far less frequently. At the same time, bearing service life is extended because contaminants that could cause wear are kept out from the start. For special applications, custom seals are also available. For example, for high temperatures, specific lubricants, or heavily contaminated environments, such as those found in sintering processes or dust-intensive operations. The permissible operating temperature of a cylindrical roller bearing depends on several factors, primarily the bearing rings and rollers, the cage material used, and the lubricant selected. In the standard design, cylindrical roller bearings are rated for temperatures up to approximately 150 degrees Celsius without any adverse changes to shape or dimensions, meaning running performance remains stable. At higher temperatures, bearing designs of the kind typically found in the aerospace sector are used. These commonly feature temperature-resistant metal cages made of steel or brass, which retain their strength and stability even at significantly elevated operating temperatures. Cylindrical roller bearings are also available as high-precision bearings. Thanks to tighter manufacturing tolerances, they are suitable for higher speeds and are used primarily in machine tools, such as turning, grinding, and milling machines. They are manufactured in both single-row and double-row designs and are used wherever a radially rigid, load-bearing, and high-precision mounting arrangement is required. For precise radial clearance adjustment, these bearings feature a tapered bore. By shifting the bearing axially along the tapered seat on the shaft, the desired radial clearance or radial preload can be set. Alternatively, these bearings are also available with a cylindrical bore. The base designations are N, NN, or NNU in the dimension series 10, 30, or 49. The tapered bore is indicated by a K in the designation, and the particularly tight tolerances are identified by the suffix SP. In our next webinar, we'll explore the fundamentals and history of self-aligning ball bearings and spherical roller bearings. If you'd like to learn more, we look forward to welcoming you back for the next session.
Vielen Dank für Ihre Aufmerksamkeit.